All right, what's up, ladies and gentlemen, to another Open Live Q&A, where I, Brian McLogan, will be able to go through your questions. I forgot to add on my annotation. I am so sorry about that. If you have some math questions, then feel free to go to brianmclogan.com/Q&A. So I'll have it up there, and what I did is I went through the questions that students have submitted last week and the week before. And that's what I'm going to do. I'm going to go over the questions that you guys submit. So if you do have a question that you want to submit to me, that you want me to go over, again, this is live. I will answer to your guys' questions. I see you guys posting into chat, but I'm going to go through the math, and then I will get to a lot of the questions that you guys post in chat. So if you have a general question that you want me to get to after I'm done with the math, then go ahead and put it down in the chat. I read each and every comment. But if you have a math problem that you'd actually like me to go through to kind of help you explain, then feel free to go ahead and submit that at brianmclogan.com/Q&A. That is the best, easiest way for me to be able to get to your math questions. Sometimes I know a lot of people want to put them down in the chat, and sometimes I can get to them, but a lot of times, ladies and gentlemen, it's kind of difficult. Because you can see, or when you see, when I go and switch to my desktop, what you'll be able to see is I'm able to cut and paste and put everything on there so everybody can go ahead and see that. So I forgot to add in. There we go. Well, good old Happy Face. Good to have you on. USA. Hey, hey. Happy to have you. And hello, B. 2026. I cannot read your name, but welcome and thank you. So I'm going to get into math, but again, get those questions ready for me, guys, and I'm happy to have you. Have you ever watched Math Endings? I have. They help me in arithmetic faster. Awesome. I love that. All right. So let's get into that. Let's see the questions that I have for today. Voila, and boom, and let's get on to it. All right. Sweet. So this student, don't know their name, said, please help me out with this whole question. It says 12 cowboys sit in a circle around a bonfire. Each observes that his age, viewed as an integer, is the average of the ages of his left and his right neighbors. Which of the following could be the sum of their ages? So let's go ahead and visualize this, right? Whenever we're thinking about a word problem, it's the age-old advice. Just draw a sketch to kind of understand what we are dealing with, right? So we have 12, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, okay? So we have a circle, and let's just go ahead and, pick a person right here, and let's say, so to the right and to the left, they got to be integers, and they are the average of the two ages of the people to the right and to the left of them. So, for instance, if we had like 10, if their age was 10, then the person to the left would have to be younger, let's say 5, and the person to the right would have to be older, right? Because you add 15 and 5, and then divide that by 2. That is how you would get 10. So the key is, for each person to the left and to the right, has to have somebody that is going to be older as well as younger. Well, when we have a thing with people with 12 people, let's go and see how this is going to work out. Now, I'm not going to actually work out perfect averages. We could do that with like 20, but there's an issue that I immediately kind of see, just to kind of see if this will work out, because let's just pretend this is person number 11. And even though this is not averages, but we know that one person to the left would have to be older, and one person to the right would have to be younger. And if we kind of follow this pattern, this person would be, so this one's older, so this person would have to be younger. This person would have to be older, so this person younger. So if I just kind of follow that pattern around, we're going to come up to a issue, right? 3, 2, 1. Because now, if you look at this person right here, the person to the left, or person however they're facing, let's say they're all facing in, the person to the left and to the right would have to both be older. So therefore, there's no way that they could be the average of their ages. So when we have this question where 12 people sit around a circle, it's actually impossible as an integer to have all those ages to the left and to the right be the averages. So then what would be the only thing that would make sense? The only thing that makes sense is if you had the same ages for everybody. So if you had 12 plus 12 divided by 2, right, that's still going to equal 12. So there's no way we can work this around where to the left and to the right, one is younger, one is older, and then that middle person do average, because you can see with 12 people, we're going to have that issue right here. Whereas, again, this person cannot have somebody too younger and too older to the right of it, just how the math is going to work out. So what that means is, the question is, which of the following could be the sum of their ages? Well, if everybody is going to be 12 years old, 12 years old, that means we need to figure out which of these numbers is going to be divisible by 12. So without getting out a calculator and without trying to do some mental math, let's just kind of work out some things we know. We know 12 times 10 is equal to 120. So if you multiply that by 20, you know 12 times 20, then it's going to be 240. Right? 240 is pretty close to what we're dealing with here. So if I subtract 112, right, that'd be like 12 times 19, that is going to be a 228. And voila, ladies and gentlemen, we know it can't be that one, we know it can't be that one, and we know it can't be that one, so therefore our answer is going to be D. Devine, if you invest $20,000 at an annual rate of 10% compound continuously, how long will it take to double your money? So Devine sent me in this question. Looks like it's something probably from her homework or a study guide. So let's go and work it out. I know with compound interest, a lot of times students, they kind of struggle with the notation, but let's here's kind of be in this functional notation. So let's kind of break it down, and then I'll give you some other notation that sometimes you'll see, and what actually a lot of times I prefer. So in this case, we have ace of t, where again it tells you what everything else, amortization function, and they tell you that the initial amount is ace of 0, and for continuous, that is n equal to large. So t, do they define t? Annual rate R, so again, that's an annual rate. So that means we're going to be dealing with things in terms of, so that'll be annual rate, and then, so we're going to be dealing with that rate is on annual terms, and then that, what that means is t is also going to be annual. It's not defined here, but t is represented in years. Now, the one for continuous interest, the formula that I remember is PERT, right? Kind of like PERT plus, if any of you guys in the United States use that. It's just, for me, it is easy to kind of remember. Okay, so P-E-R-T. All right, and crap, I forgot. Maybe like A to your final amount. So let's kind of go through what these are all going to represent. It doesn't matter if you're using A or ace of t. Obviously, this is function notation. But this is going to represent the final amount. Okay, and then just like they defined in this problem, the ace of 0, or P, which would be like the principal, this is going to be what we call our initial amount. So this is going to be the initial. Okay? R is going to be the rate, and again, that's going to be annualized, and just make sure that we're going to be using that as a decimal. Okay? So R is going to be the rate, and then T is going to represent the years. Okay? And then from here, really, guys, it's just going to be kind of a plug and chug. Now, let's go through the question that they have. They sent over 2 questions, 4 and A. So let's see how, they said the double money, but let's just do 5. Why not? 4 and 5. So in this one, it says, if you invest $20,000 at an annual rate of 10% compounded continuously, so again, that compounded continuously is what triggers me to know to use the PERT or the function that obviously they provided, how long will it take for you to double your money? All right, so let's just go and list down the things we know. When we're working through, even like work around with this, again, let's write down what we know. We say you invest $20,000, so that is our initial amount, right? So I'm going to say ace of 0, I'll use their notation, is going to be $20,000. We have a rate of 10%, so our R is going to be 0.10. Because remember, ladies and gentlemen, if I have 10%, if I want to rewrite that in terms of a decimal, all you simply do is move the decimal point over 2 units. And then how long will it take to double your money? So T is going to be what we are solving for, and we need to figure out what is our ace of t. Well, it says we want to know how long is it going to take for us to double our money. So we take in $20,000. If that money is doubled, then we would have how much? $40,000. So our final amount is going to be $40,000. So let's go and write out the formula as we have it. So we have $40,000, and it's going to equal our initial amount times e to the 0.1, we don't really, 0.1 t. All right. Now, the cool thing about these double and mono formulas is it doesn't really matter what these numbers are, because the first thing you're going to do to solve for t is you're going to divide by your initial amount. Right? What happens when you divide, when you're doubling an initial or a final value that was doubled from the initial value? You're just going to get the number 2. So 2 is going to equal e to the 0.1 t. Now we need to figure out, well, how do we solve for t? How do we get t off of a power, right? So we got to think of our inverse operations, right? When we're solving equations, right, the inverse operations like to undo addition, use subtraction, right? To undo subtraction or to undo multiplication, use division. To undo the square root, use square. Those are your inverse operations. If I want to undo taking the power of something, what I'm going to do is use logarithms. Logarithms allow us to undo that variable in the power. So what I'm going to do is I'm going to take the natural logarithm or logarithm of base e, because you always want to take the logarithm for whatever the base is that you need to get rid of to your t. So I'm going to do natural logarithm base 2, and this will be the natural logarithm base e of e to the 0.1 t. Now, using our rules of exponents, what this is going to give me is that ln of 2 is equal to a 0.1 t. Now, to divide by t, I'll divide by a 0.1 on both sides. I'll flip it around, and I can see that t is going to equal ln of 2 divided by 0.1. Now, we are going to have to go ahead and revert to our calculator. So let's go and do ln of 2 divided by a 0.1. And this is giving me a 6.9 years. So does not tell us how to round our time, so I'm just going to say t is equal to 6.93, and I'm going to write years, even though that's what t is defined as. All right, let's go and take a look at number 5, because I don't know, the student sent it, so let's go and take a look at it. It says, what are the amount of money you must invest at 5.5% compound continuously in order to have $15,000? So again, what do we do not know? It says, how much money must you invest? That is going to be your initial amount. So I'm just going to write a sub 0. I do not know. That's what we need to solve for. It's going to have a rate at 5.5. So again, move the decimal point over 2 spots. It's going to be 0.055, which is actually very interesting. The amount of my studio percentage to my whole house is actually 5.5%. I was just rounding out some taxes, and so I had to use that number, so kind of interesting. Compounded continuously, so the final amount is going to be 15,000. So a sub t equals 15,000. And then t is going to be 10 years. So t is equal to 10. All right, let's go into the problem again. So we have 15,000 is equal to my a sub 0, which I do not know, e to the 0.055, and then times 10, which is technically just now, all that's simply going to do is move my decimal point over 1 unit, right? So it's really going to be 0.5. So let's just go ahead and simplify that. So 15,000, a sub 0, e to the 0.55. Okay, so now we need to solve for a sub 0. So all I'm simply going to do is get rid of the multiplication by e to the 0.55. So e to the 0.55, divide that on both sides, and then I'll have to go ahead and use my calculator to see what that is. So I'm going to take e raised to the 0.55, and I'll take 15,000 divided by that answer, and I get 86,562. So that means an initial amount of 86,542, and then I'll do 47 cents. Okay, now, one thing I actually forgot to mention, whenever you're working through kind of workarounds, it's also important to make sure that things make sense, right? So let's actually go back to number 4. And so if we have an initial amount of $20,000, and roughly you're getting, 10%, right? 10% compounded continuously. Does it kind of make sense in 10 years, right, at a 10% rate, or not 10 years, in 6.9, so almost 7 years, that you'd be able to double your money? And I'd say, yeah, all right, that looks reasonable, right? It's not like 0.9 years, or it's not like 69 years. That seems pretty reasonable. What about over here? If I wanted to see what amount of money must have been at 5.5% continuously to have $15,000 in 10 years? So again, I want to see how much should I invest to get 150 or to get $15,000 or 150? $15,000. Oh, I made a mistake. What did I do? Um, 0.00 and then 10 years. 0.55. The rate times time. A sub t is 15,000. Oh, I typed in 150,000. No wonder. I was wondering. I'm like, what did I do wrong? Sorry about that. So 1.733253018. Okay. Yeah. So that makes absolutely no sense, right? I caught my mistake. Does it make sense? Think about this. So this is where I caught my mistake. It was actually like I typed in the wrong number. I typed in 150,000 instead of 15,000. But notice, before I even caught that mistake, I noticed it always makes sense to check your work. So listen to what I'm doing, because this is very important. Does it make sense for me to invest $86,000 at a 10% rate and after, or at a 5.5% rate, and after 10 years to now have $15,000? No, that'd be a negative rate, right? That doesn't make any sense. So obviously I did something wrong, and that's where I was able to catch. I typed in an extra zero. So I typed in 150,000 instead of 15,000. So that doesn't make any sense. But when I do work it correctly, what the correct answer is, A sub 0 is going to be 8,654.24, right? And we're just going to truncate it and not leave it rounded. That is going to be your correct answer. So just make sure when you are working through these word problems, just make sure it kind of makes sense, right? And you can see that obviously investing $86,000 and having a growth rate and then getting something smaller made no sense, right? But I was able to catch my mistake because I was just working my way through it cautiously. All right, I love this. The LOL frog. On YouTube, I don't understand. Oh, that's your YouTube video. Awesome. I don't understand why both methods are right, most likely, but the answer is different. Okay. So the question says, what is wrong? This cube root, or the sixth root of -8 squared, and then they go to the cube root of -8 is equal to -2. All right, so looks like, so nothing or something. So if nothing is wrong, it looks like they used the rules of x of rational powers. So they rewrote, so they rewrote this as a rational power. So the sixth root to 1/3, right? So they rewrote as a rational power, that's good. Then they reduced it, and then they took the cube root of negative number, which is a -2. Gotcha. And then over here, they simplified under the radical, and then took the sixth root, and they got 2. Okay, so here is the thing. This is the correct answer. This is an extraneous, I'm not even sure of an extraneous answer, but it is not a real solution. Here's the way that I can determine this and kind of see where the mistake is. So, what do we know about the square root of x versus the cube root of x? Okay, well, let's go and take a look at the graphs. The graph of the square root of x looks like this. The graph of the cube root of x looks like this, right? So what are the differences? Well, let's talk about the domain. The domain of this function is for all positive numbers, right? It's only from 0 to infinity. Whereas the domain for this function is all real numbers, from -infinity to positive infinity. Now, the cool thing is about these functions is, ladies and gentlemen, it doesn't matter if I'm taking the square root or the sixth root. The domain is exactly the same. I don't know what this graph looks like, but I do know there is a domain restriction on the sixth root of x, because if you're going to take an even root of a radical, it has to be power. It has to be positive, right? So you can't have a negative number under here. So I don't even know what this graph looks like, but I do know that it's going to look, something like that. So this function has a domain restriction for only positive numbers. Okay? So let's look at what the problem is when we work through on this left-hand side. We started with the sixth root. right? The sixth root. So it's important that we identify our domain restriction. The domain has to be from 0 to infinity, right? Because again, when you're taking the sixth root, you're saying what number multiplied by itself that many times. So the square root, what number multiplied by itself twice, right? Or 2 times 2, or 4 times 4. The sixth root would be what number multiplied by itself, 6 times. So in this case, you can't have that number that you're taking the even root of be negative, because a number multiplied by itself 2 times or negative or 6 times is always going to result in a positive number. So that's why we have to have this domain restriction of 0 to infinity. So the work that happened is even though they correctly were able to utilize the conversion from a radical to rational powers, but once they simplified it, what they did is they changed the function. They changed the function from a sixth root function to a cube root function. Well, ladies and gentlemen, the cube root function has a different domain, right? So we still have to, no matter what we do to simplify from this, we know that we have to still abide by our original domain restriction. It's just like if I had this, and this is one thing that we talk about with compositions of functions. If I had like f of x equals x squared, and then I have g of x equals the square root of x, right? Now, obviously, this function has a domain, does not have any domain function or domain restrictions. But this function does have domain functions, right? So the domain has to be from 0 to infinity. But if I go ahead and do, like, what is the domain of, and if I do f of g of x, ladies and gentlemen, you have to still abide by this domain restriction. You can't just get rid of it. So what's going to happen is we're going to get the square root of x squared, which is just going to give you x. But that is going to be the composition, but the domain restriction still applies because this was our input variable. So the domain is still going to only be true from 0 to infinity, right? You can't just like ignore the domain restriction. And that's the same thing here. Just because we simplified this over here, we just can't now say that negative 2 is now possible because you're changing the function. You're changing the function and forgetting about this domain restriction. So the correct way to approach this problem would be exactly what you did over here, would be to simplify under the radical and then take the sixth root. So hopefully that helps explain things. You can't just ignore domain restrictions of your original function. Find the inverse. So in this case, we have fx equals 8 raised to the 2 raised to the x. And what are we going to do? Okay, so let's just go through the steps of finding the inverse. First thing to find the inverse, replace f of x with y. That just helps make the math go a little bit easier, right? So step number 1, do that. Because you don't want to be using function notation. Step number 2, swap the x's and the y. So I have an x equals a 8 to the y. Now again, step number 3 is to solve for y. So we have to be able to get this y off here as the exponent. But you can see there's kind of like 2 different exponents, right? We have it as the exponent of 8, and then we have y as the exponent 2. So we're going to work from the bottom up, okay? How do I get rid of this base 8? And that comes into using your rules of logarithms, right? If I have the log of 8, let's use letters, of a, or base a of a raised to the n, then that, ladies and gentlemen, is just going to equal n. If I have log base a of n raised to the x, that is just going to equal an n to the x, okay? So what I'm simply going to want to do here to get rid of this base 8 is I'm going to take the log of base 8 on both sides. So I'll have the log of base 8 of x is equal to the log of base 8 of 2y. Now again, that is just going to simplify, there we go, of 8. Wait a minute, what am I doing? Yeah, log of base 8. Sorry. I took the log of base 8, there we go. Oh, shoot. I knew I wrote something down wrong. Sorry. It's going to look like this. So this will be the log of base 8 of 8 raised to the 2y. Now, that is going to simplify, so I have a log of base 8 of x is equal to 2 raised to the y. Now again, I got to get rid of the 2, right? Because I got to get this y by itself. So again, to get the y off the power, to get rid of that base 2, I'm going to take the log of base 2 on both sides. So now it's going to be log of base 2 of the log of base 8 of x is equal to the log of base 2 of 2 to the y. But now I can get this y off as a power, and I can rewrite this as y log base 2 of log of base 8 of x. And now, since we originally had this problem in function notation, I can rewrite this in inverse notation. So f inverse of x is equal to a log base 2 of log base 8 of x. There you go. Hope that helps. All right. So if you guys have your own math questions you want to submit, again, go to brianmclogan.com /Q&A. I might be able to do some more math questions. We'll see. I think I have an extra space here. That was a long question. Or not really a long question. Somebody submitted this long thing for me to be able to do. But let me go and see. I might be able to get some other math questions, but the best way, the easiest way for me to be able to answer your math questions is simply, ladies and gentlemen, to go to brianmclogan.com /Q&A, and I'll answer your questions. But now what I'd like to do is get inside the chat and address any of the questions that you guys have added to me. Let's see. What can I do? I wanted to, there we go. Okay, cool. Where do they go? Oh, I can't move it over here. Oh, yeah, I can. Oh, actually, awesome. Can I move this over? No, that's annoying. Okay. Hey, Lemmy, good to have you on. Hello. Yes, that is a lot of Arabic, and I do not understand it. I apologize. Hey, Andrew, good to have you on. That's a great one. Go ahead and submit it at brianmclogan.com /Q&A, and I'll be happy to go ahead and take a look. Hello, is it normal that the sound has like a reverb? My sound on this, I don't know. I didn't check it. I don't think I have. Thank you so much for letting me know. There we go. Does that sound much better? Give me a thumbs up or a thumbs down. I apologize. I did not know that I had a second camera or a second microphone that was playing. So let me know that that is sounding better. Oh man, that sucks. That means I just went through this whole live stream and all those explanations and the microphone was sounding so bad. I'm sorry about that. Well, thank you so much, Charmer Jeff. I really appreciate that. Yeah, I had an extra mic going on. Man. Dang it, that stinks. All right, well, whatever it is what it is, I guess, from now. So crap, I'll probably need to go back and re-record those, but is what it is. I am doing good. There's an echo. Yes. Is it still an echo? Though I don't know how long that came through. So if there is, I apologize. I can go back through and check to see if I have a sound check. Otherwise, this live stream is a bust, and that is what it is. But it's yeah, I only have my Elgato going on from now, so it should be good. So let me know in the comments, is the audio much better? Yes or no? Let me know. Otherwise, I'll probably have to go back and record on that function. Crap. Oh, well, thank you so much. All right. Well, ladies and gentlemen, I will be back next week. And if you guys have your questions ready, then bring them on. I'll be ready to go to answer your questions. And hopefully you guys, let me go and check. I forgot to add in my poll. See what you guys have on the poll. I know it's not a ton. Okay, good. Get an A. Awesome. Not fail. Love it. All right, very good. Thank you so much, Benny. I appreciate it. Let me know. But yeah, questions a little late. Well, I'll be ready for you guys next week. Get those questions ready to go. I do apologize. I know. I didn't know when I was going to be able to go live today. So I just had to pop it when I was ready. So, all right. If you guys have questions, math questions, submit them at brianmclogan.com /Q&A. And then Well, I mean, do you have a math question, Benny, or do you have like a general question? If you have a general question, I'll be able to answer it. Math question, I mean, I'll see what I can do. But type real fast. I don't have time to open up the form though, because I already closed it down, unfortunately. So it's going to take a second. But if it's straightforward, I might be able to help you out. All right. Let me see if I can do that. All right, Benny. Sorry about that. Now that you did this, how to solve polynomials higher than y squared. I'm going to have to click back through. I shouldn't have closed it down. I apologize. Well, yeah, I just need to look at what type of problem you're dealing with. And then once I see, I'll be able to work at it. So hold on. I'm just clicking my way through just to get there. Almost about halfway done. Almost. We're getting up. If it's next week, no problem. No worries. Well, I'm just going to go and take a look at it. And so I can add it in there. I mean, I'm already on the live stream, so it is what it is. So we'll just sit and wait, and I'll see if there's any other questions that come in as I'm going through. I apologize. Man, I'm so pissed because I worked through, I mean, part of that reason I went through on the live stream so I could go through some of those questions and repost them on my other channel. And now I'm pissed because those videos are, I'm going to have to go back through that math all over again. I mean, I guess it wasn't that bad. It was only 30 minutes roughly, but is what it is. All right. 40 more questions left. I still have 144 questions to go through. And so I feel so bad because I tried to keep this like on then, but students just kept on submitting questions. And I used to live streams when I was doing it last year. Like I would just answer like non-math questions for like over an hour. And it was awesome. I loved it. And, but yeah, so a lot of the math questions just never got answered, but I always want to get through. All right, Ben, I see you. Find solutions. I'm not sure how to solve polynomials higher than 2. I use ChatGPT for this one to memorize everything, but I'm really stuck on how to solve these hard couple examples. Let me see. So those tick marks are represented as powers. I've never seen that like notation unless we're looking at like the derivative. Is that confirmed, Ben, that those are represented for on the powers on that? Let me know so I can kind of take a look. But yeah, finding the general solution of higher, do you have to use factoring or, I mean, that's, yeah, for the differential equations. Yeah, it's been way too long since actually I never even covered what the differential from on there. So sorry. The first step is to solve the polynomials. I gotcha. I would have to go back through. It's been way too long since I did any calculus or even taught in the calculus. So sorry, this would be something I would have to go back over and look through for on there. But I never taught with the differential equations and looking into solving the polynomial. I mean, there's some factoring techniques, but they can get pretty messy, especially when you're dealing with these higher order ones. So, but there are a couple texting used, but I'm not sure what exactly would be the best approach for on these. I'd have to go back and review like old notes and stuff like that.
I mean, typically when you're dealing with something solving for as far as the higher order, you're looking into like, looking into doing a possibly like a factoring, by grouping, but I'm not even seeing these. It would be possible by a factoring by grouping. But yeah, I'd have to go back and review. Sorry, it's nothing that I currently, cover quite a bit. So I would just have to go back and review the stuff. So sorry about that. I would not be the best person to go back and review that for you. It's just been a little too long, a little too rusty in that regard. But anyways, wish you best of luck. And if you don't mind, keep me posted. I'd love to actually, if you submit that over and I can go and take a look at it, I would actually really appreciate to go and take a look at to see where you came from. So you can go and do that again at the same link and I will see it. So thank you so much, everybody, for hopping on. I will see you guys next week. Cheers.